Okay, 5-4, day 2. All right. So we've got a population has a mean equal to 33 minutes with standard deviation equal to 4 minutes. And these time values are representing the time spent reading a newspaper. You are going to randomly select 35 people from this population. And find the probability that the sample has a mean time between 32 and 35 minutes. Okay. That's a long example there.
Not a good day, Mrs. Swartz.
Well, too bad.
No
So,
paper, my pen just died.
probability is the question, finding probabilities. And we know that this normal distribution table is full of probabilities because it's giving us the area. Remember, areas of probability? Up until this example, I always told you that a population was normally distributed. Did I say that about this population up here?
No.
No. So I don't know what shaped population I'm drawing from. So the population could have some ugly distribution. Oh, I keep doing that. Okay. This is the population, but I know that the mean is 33 minutes and the standard deviation is 4 minutes. Now I'm going to select samples of 35. What was the magic number yesterday that said if I took at least this many, it was always going to come out normally distributed? 30. 30 is the magic number, and I hit that magic number. So that means my new distribution for the picking sets of 35 will be normal. Okay, what's the mean of this new sampling distribution? Still 33. But the standard deviation changes. Do you remember that? Standard deviation gets smaller. How do I calculate the new standard deviation? Take the old one, divide by square root of 35. And we're just going to leave that as that ugly number for now. So now my probability question is coming off of this graph. And the question I'm asking is, what's the probability that a randomly selected group of 35 has between 32 and 35 minutes? So we're looking for 32 to 35. We're looking for that area. Well, how am I going to get this area? Z-scores. You need the Z-scores for those two spots. Then we grab our table, look up those two areas, and then do what with the two areas? Subtract them. So, we're at the point where we're just like we've been doing. The only thing different here was because I was taking more than one, I had to make sure that my new distribution was going to be normal, match numbers 30, calculate a new mean and standard deviation, and now we just go through what we've been doing. So we need the z-score for 32. So that's 32 minus the mean of 33 divided by that new standard deviation. Okay, people mess this up all the time on their calculators. Even though they write it down right, they won't calculate it right. If you take a look at that, where are you going to need parentheses at? This and this. You need parentheses around your numerator and denominator. If you're going to type that all in one line, I mean, you can do it in a couple lines, but so practice it. See if you can get that right z-score on your calculator. And we want the z-score rounded to the second place because our table goes out to the hundredths place. What are we coming up with? I'm hearing negative 1.48. Agree?
Yeah.
All right. Everybody was okay with that? All right. So now you do the z-score for 35. So 35 minus 33 divided by that 4 over square root of 35. Parentheses. Remember how you can do that second entry thing and you can just go back and retype over that number instead of retyping the whole line again. And what's this z-score? 2.96. Now you're ready to go to your table, find the two areas behind them, and subtract. So the negative 1.48, 0694, if my eyes are correct. That'll be the one that's being subtracted. What was the, anybody look up the 2.96 one? 9985. Do a little subtraction, and then we'll have our probability. $9,291? That in my head. Okay, so that's what we're doing today. Making sure that your new distribution's normal. So if they don't say anything about the first population, you assume it's not normal, then you've got to have 30. Otherwise, you can't do the problem. Number 2. Okay, the average selling price of all homes in the United States. Is $125,700, and this was, remember, back in the late 90s, so I'm sure it's higher. With standard deviation, $26,000. Home prices are normally distributed. You are going to randomly select $16 homes and average those prices together. Find the probability. That the average is less than $120,000. So first of all, the part in here that's telling us to do that, oh, what's my population distribution, what's my sampling distribution, is the fact that we are selecting more than one. That's where we're going to have the two graphs going on, the population graph and then the sampling graph. Where before, when we were in 5.3, we were only selecting one thing out of that population, so we didn't make two graphs there. So, this time I tell you that home prices are normally distributed. So here's the population normally distributed. The mean is 125,700. Standard deviation 26,000. Selecting samples of 16. That's under the magic number 30, but is it okay? Yes. From yesterday we said if the population started out normal, you could pick some under 30 and still be normal, except the standard deviation does get smaller. Mean stays unchanged. 125,700. Standard deviation gets smaller. Take the 26,000. Divide by square root of 16. So I could have put a 4 down there. And now our probability question is coming off of this graph here. It's the probability that the average is less than 120,000. So 120,000 is going to be back here. And we're looking to be less than. So we're looking for that area. So this time, all I need to do is look at the value that's on the table, because that is the value behind, but I need the z-score for that spot first. So the z-score for 120,000 I'll just put a 4 down there since that one's easy enough to do. But again, make sure you have parentheses around your numerator and denominator. Z-score out to 2 places. And what's the z-score? Negative 0.88. And now look that value up on your table. What is it, 1894? So that will be our probability. Good. Number 3. The average price of a 4-door sedan. I must have looked this up more recently. $35,700. With standard deviation, 1,200. You're going to randomly select 10 4-door sedans from this population. I'll just say 10 cars. Find the probability. That the average price for your sample is over 36,000. we're selecting 10, so that tells me I've got to make the 2 graphs. Here's the information about my population up here. Do I tell you that the population is normally distributed anywhere there? No. So the population doesn't necessarily normal, but I know that the mean 35,700, standard deviation 1,200, selecting samples of size 10. What do I know about the sampling distribution shape? I don't know for sure that's going to be normal because I didn't hit the magic number 30 from a non-normal population. So, can't tell what this is. Problem's done.
We need to have all,
So, do you think I'll have one of those on the test?
I think so.
Yeah, but how many people do you think actually pick up on the fact that you can't do it? People go through, give me a normal with that mean, divide this by square root of 10, like they know what they're doing, do the whole problem. -4. Doing all that extra work for nothing. Ooh.
Wait, okay, last example,
Number 2, yes.
what was the n equals something? N equals something. I didn't realize that we had to do that.
Because it's not normal.
And that's from yesterday. I can show you real quick because I've got the notes right here. Remember the 2 parts? You had, if it was not normal, you had to have 30 to be normal. If it starts out normal, the sample would be normal no matter what. So that was the 2 parts of the central limit theorem. Okay, the assignment I have written somewhere.
Yes, now I got it.
Page 2, 32, 13 to 22. Got the page number written correctly this time.
I like it when the there's 2 pages are on like back to back.